Fourth one, data center environmental efficiencies. I think that's still, a really hot topic. Sorry, but it continues to be an important aspect of what we do, and I'll talk a little about how I've seen some of the trends change even in that one over the last 3 or 4 years. And certainly like to get you guys' read on these things as well. And last one is when I put this one in. It's not really a trend that people normally talk about, but I think it's kind of sitting there all the time, which is how do we take complexity out? How do we take complexity out of provisioning and managing IT and keeping up and running and all the good things that we need to do? And I think it's very easy for us as an industry to put complexity into the system. And I think we've done a fabulous job of that as an industry for many years. I think the opportunity to really figure out how we take some of it back out again. So what do you guys think? So I told you I was going to make you guys try to talk. So I'll start with cloud computing. I mean, is this, you guys, what do you guys think? Is this #1 trend right now? People are thinking about #1 buzz?
Everyone talks about it.
Yeah, everyone's talking about it.
But it's got different viewpoints.
Yeah.
I don't think that's a good enough definition that everybody can agree on. Because cloud is different depending on who you ask.
Absolutely.
What context you're discussing it in.
Mm-hmm. Any other thoughts on it?
There are many reasons why we don't need it.
Many reasons why we don't need cloud, huh?
When you speak to people.
Yeah. Silence. So what I'm going to do is I'm just going to, I've got literally 2 slides. This is my overview slide, and then next slide in is really just kind of go through really notes for myself, remind myself, what I want to talk about. But cloud computing. So what is a cloud? What is and I just kind of put in a few questions here. What is a cloud? Does it matter whether it's public or private? When is it really prime time? Does it really matter? Is it going to be a niche, or is it kind of mainstream, kind of core, kind of stuff? And I think perhaps probably the best place to start is what is a cloud? And so I think one of the things whenever I talk to customers about clouds, the first thing I always feel like I have to do is say, well, when I say cloud, what I mean is this, because until you actually get that definition out there, it's kind of difficult to even have a discussion about what you're talking about at all, because it's all over the place. In my experience, thanks, Ken. So,
Need one?
I might need one, yes. Leave one out. So. In my experience, what's it called, cloud washing, I guess is where vendors, will, everybody talks about cloud. Like I said, they're all talking about they're doing cloud and stuff like that. And I kind of joke is that what usually when people say cloud, what they mean is if you buy my widget and you plug it in with a bunch of other smart stuff, assemble it in just the right way, you can actually construct a cloud. And so by that definition, a power supply is a cloud-enabled power supply, right? So it doesn't, anything is cloud-enabled, by that loose of a definition. Obviously, I don't think that that's very helpful, for the industry. I think it does need a little bit clearer of a definition. And so the definitionally, the way I like to think of it, right, I would propose, is how we think of a cloud is one is that we have a pool of resources that can be used, configured any one. 2 is we allow users to request a service that they can consume some of those resources in the pool. And when they request it, based on some sort of rules that, varying depending on implementation, but some sort of rules around the request, they will then be granted those resources which will configure themselves to match what the user wanted in a matter of minutes. And that means you have to be able to go and find the appropriate resources, configure them, and then deliver them to the user. And then the last component is you have to be able to charge for them. And the charge is in a way kind of a little bit optional, because in some cases if it's a private cloud kind of implementation, internal use, they don't necessarily, the chargeback is not as formal as if it's a public cloud, but you need to have that ability or that means to do it. And so, in my mind, that's kind of the minimum, set of definitions. And I think there's still a lot of room for for different varying implementations within that, but I think at least it does constrain it down to something that, you know, like I said, I can't get back to my power supply being that definition. So, I'll pose that as a definition. I'm okay with having, you know, other people having differing opinions on it, and if anybody just are you guys okay with that definition? Does that seem reasonable to you guys? You know, if not, then, you know, jump in and say so. But that's kind of, you know, my minimum thinking. You know, you got to be able to have some way to kind of define it. Now, within that context, then of you know, what I view at least as a definition of a cloud. And by the way, I think it's, you know, the reason why I found it was important to have one is not just so I can talk to you guys, but what I think the definition is that way we actually know what we wanted to produce, you know, in our products and technologies. But within that, then the next question is, you know, how widespread is this? And, you know, today, you know, obviously cloud usage is, you know, like I said, people are talking about it, but not really doing it, you know. So it's, you know, by and large, you know, the overwhelming majority are not doing it. So one of the questions I always have is, you know, is this going to be a niche? Is it going to be even an important niche, you know, like high performance computing? You know, I mean, there's a lot of high performance computing out there, but it will never be 100% of the market. It'll never be like the majority of the market. You know, so the question is cloud going to be kind of like that, or is it going to be mainstream?
So one of the things that I think might be missing from your definition of cloud is sort of the elasticity component, where if a user requests resources and then they suddenly realize that they under requested, that they don't have to blow up what they did and start over, versus just being able to expand the scope. So, because I think without that piece, you're sort of back to the I might as well just have client, or you're like a client server model.
Right. Yeah. Yeah. No, that's a good thought. Actually, I like that, and I agree with that. I agree with that. That observation too, and I think that's an important part of what you have to be able to do.
Should this service be smart enough to ramp up provisioning on its own?
Well, that would sort of be the last. I mean, an elastic cloud, that by definition, that's what it would do. Or
at least have the option to do it.
Yeah.
Depends who's paying and whether they want that.
Well, obviously.
I want my application to work always on demand, but I'm not paying for it if it's going to cost me an extra 4 pence. It does depend what the application is, what the tier is, what the business impact of it being down is. But then that depends on whether you put something really important on cloud, or whether you buy in capacity or service as required. The fixed for the variable cloud.
So I think that comes to almost to the crux of my next question, which is, you know, is this going to be a niche or is it everywhere? And I think it depends a lot on, you know, how are you able to respond to those kinds of questions. And, you know, today, you know, what people think of a cloud, and it's like anything else, is in a maturity stage where the answer is not always yes, you know, to everything you'd want to do. And in some cases, like I said, there may be business rules that say things like, I want to let this one expand, or I don't want to let this grow because I just don't want to pay more than this amount for this particular service, or this service is more important than that one, so I don't want them to overrun the wrong one. Yeah.
It's also defining what's core to business and what isn't. So if it's commodity service and buying, then cloud HPC is fine. Requesting virtual capacity is fine, but I might not put my trading app on it or my proprietary app that I spent 3 years writing for a number of different reasons. Cloud is going to be used, but it's going to be used on a per business basis. And I think small businesses will be adopting it first because they're the ones that say want an email service and someone turns around and says that'll be thousands of dollars. Well, Gmail's $9.99 a month.
Yeah.
That kind of scenario. Baby steps. And
well, even in the small business scenario, I know I oversaw a small business configuration of like 20 servers, for lack of a better description, that were deployed inside like RightScale's environment, and the ability to do something like that and minimize the number of like system administrator skill sets that you need inside an organization in a cloud infrastructure is vastly different than if you had servers in a rack that you had to deal with.
Yeah.
And I realize 20 is a really small number, but
it's a real number.
Yeah.
Yeah. There are companies out there like that. Yeah. So okay, so I'll go ahead and I'll throw my thought out on this too. So first off, so I think y'all are all right in this. And you know, so part of it is, I mean, I didn't specify public or private. And in my definition, if you notice, I didn't actually say anything that would require it to be public or private. And so I think even in a private cloud, I think I could see customers putting their trading applications or whatever that they spent years developing their own application and writing it. That's because it's still within their four walls. It just has the added benefit of having the elasticity and the on-demand provisioning and stuff like that, which are goodness. So so I see that happening a lot. I think for the reasons you said too, on small businesses where you can say, it changes or reduces the kind of expertise I need to have on staff, on site. I can see that as a compelling reason for smaller companies to want to move to public cloud computing also.
It's also coming from a vacuum of delivery, in that if I turn to IT and say, I want this, more capacity for PeopleSoft, if they're turning around going, yes, but in 17 months, well, I can buy it in from vendor number 9 as a service. I don't have CapEx, I don't have a degree of physics, it just gets done. So it's going to be both. IT needs to gear up.
Yeah.
Business teams need to understand their rules of engagement, as in what is it you actually want delivered. And the two need to come together, and it's a convergence of the enterprise, so to speak.
Yeah.
So there's a cultural process change in IT and business in terms of accepting costs and accepting operational risk.
Mm-hmm. Yep. I agree. So I think this gets to, the point I would make is I think ultimately cloud is going to be ubiquitous. I think it's everywhere. So it'll be public clouds, private clouds, it'll be all of them. Those risk questions, have to get addressed in an appropriate manner, and I can see large enterprises still, not necessarily, they may leverage public clouds, but not necessarily, for their core applications. I think they have a private cloud for their core applications, some that they can say, I can, this one I'm less concerned about. I'm just going to outsource it wherever it makes sense. And for smaller companies, they may just have to pick and choose which, as a service provider, they want to go with for something. So the reason why I get to this point is I think you'll see this as kind of going to be certainly biasing my behavior. I think HP's overall as well. And when we think of clouds, I think this is I believe this is where the industry is going to go, and I think that the benefits will ultimately outweigh any problems that exist today with it, which there are many, and you guys have articulated some of them right there. So
sorry, not also the bridge towards the virtual data center, where I have services and applications that run somewhere.
Yeah.
But where legally I may care where they run, but operationally I don't provide the work. So if I can have my IT run in the back of a van in India for £17 rather than £300,000 in the UK, then that might make more sense to me operationally. But if we move towards the follow the sun model and we virtualize the application served with a data center, there's no reason why we can't have high availability and low cost compute by just moving it around the globe.
Yep.
Now obviously it's not going to work for the small business necessarily, but for the enterprise you might have a cloud which just moves around the sun, or the opposite way, depending on whether you want the lowest cost or the best energy efficiency.
Mm-hmm. Yeah.
So cloud is a way of providing service, but I think it's also a stage towards virtualizing everything and having it move wherever you want it to be.
Yeah. Any thoughts from you quiet guys over here? So, and make sure I'm going time-wise. Okay, so I'll just say, I think all these things are valid things, and I think ultimately cloud is going to be happening everywhere. From an HP standpoint, you'll see us continue to drive a lot. Jim kind of mentioned, you see us making more announcements and activities on this front going forward. We've been investing heavily in this space. Jim mentioned Blade System Matrix, and you guys got to see some of the work that we're doing yesterday when you're up in Dallas around there. Really, I think what we think of what we call cloud computing, certainly from a private cloud standpoint, we've been actually working on this for about 10 years now within HP. So long before we even knew to call it a cloud, we were basically developing cloud-like technologies, because it's really where we knew we always wanted to get to. Now, we didn't know the exact particulars of how we're going to do it and stuff like that. We learned a lot as we went. But I'd say that we are, one, definitely thinking that this is, the future in general, not biasing to being public or private, recognizing that there are real concerns about security and legal and things like that. But we think that that's ultimately the right computing model, and so you'll see us continue to invest heavily in that way. Convergence, second big topic. HP, of course, has been talking about converged infrastructure for a long time. I think virtualization is one of the trends that really kind of has driven convergence, actually, because it's, we've moved from a model where we kind of think of it as you have servers, storage, and networks, into a model where you have converged infrastructure with virtual workloads on top. And that's really kind of the mental model I have anyhow, that is moved to that model. So convergence becomes a really important thing. I want to talk about a couple areas of convergence also. And this one is the fabrics. And of course, there's a lot of converged protocols out there with things like fiber channel over Ethernet and iSCSI and things like that that allow you to run storage traffic over Ethernet. There's also a lot of protocols that are being developed, like single root I/O virtualization and virtual Ethernet port aggregation technologies that are designed to really kind of simplify the way we run virtual workloads over networks also. And we've been real heavily involved in a lot of those standards works and activities. One of the things you get to see today is our new Gen 7 servers, and on the Blade servers we have what we call a Flex Fabric adapter on the motherboard of all of our servers, and this is we've announced this about six months ago, I guess, in terms of what it was exactly, but something like that, and is now widely available. I'll start with kind of fabric convergence. So what we've seen is over the last year or two a big push towards fiber channel over Ethernet. I don't know if you guys have an opinion on fiber channel over Ethernet. I think mine is kind of great in some places and not so not necessarily as compelling in other places. Our observation is first off, I mean, at the edge, at the server edge, fiber channel over Ethernet we think is a real obvious good technology to take advantage of, and we've got that in our Flex Fabric adapters. Basically, it's embedded in. So what you can do is our Flex Fabric adapters on the motherboard, 10 gig adapter can be automatically configured to carve it up into up to 4 adapters each, and then you can specify the bandwidth across all those 4 adapters. So you got 10 gig, and you say I want it to be a 4 2.5 gig adapter, so you can make it a 4 gig, a 3 gig, a 2 gig, a 1 gig adapter, whatever you want in 100 megabit increments. You can assign out the bandwidth. And then the other thing you can do is you can assign one of those adapters to become a storage adapter. It can be iSCSI or fiber channel adapter as well. And so by doing that, it allows you on the motherboard to be able to just kind of snap your fingers and create the number of NICs and adapters that you want on the fly for whatever you want. And of course, virtualization typically wants 6 NICs and 2 fiber channel adapters. So surprise, surprise, we've set it up such that you can, on the fly, instantly create 6 NICs and 2 fiber channel adapters right on the motherboard of the servers. We think that's kind of an interesting way to do convergence on the fabric side, and I think it's an important way to do it. And for many applications, 10 gig of bandwidth is going to be adequate, spread across all those things at the edge. Now, once you aggregate, that traffic, then you have to send the traffic out after that. And I'm going to pause on this. I mean, how familiar are you guys with fiber channel over Ethernet? Have you guys spent any time studying it or looking at it, or? Yeah. Yes, no?
I've looked at it.
No.
But not that much.
Not much. Yeah.
Yeah.
Yeah, I mean, it's kind of one of these things that kind of got a lot of buzz, and then just kind of, I don't know. I mean, I don't hear as much buzz these days about it. Not, just in terms of strong interest. I think people are kind of recognizing its
got a place and used in some
There's
places.
an awful lot of talk about it, and there are supposed to be a whole lot of standards set, and then it kind of went quiet and disappeared off Ethernet.
Yeah.
So actually, one of the things I like about cloud computing is that I stop having to think about things like that.
Yeah. Somebody still has to think about it.
But it's not my problem.
Yeah. Well, you know, I think actually even if you're constructing a cloud, we would like it to not be your problem, honestly. You know, I mean, our goal is that, you know, as much as we can just kind of make this stuff work and, you know, not have to worry about all the minutiae of, you know, where the electrons are flying around and stuff like that. You know, this should be, you know, our job as the product guys designing this stuff. You know, I'll just say fabric convergence is kind of an interesting topic. As I said, fiber channel over Ethernet allows you to run fiber channel protocols over the same Ethernet wire, and we think it makes a lot of great sense at the edge. When you move to the core of a network, it gets a little bit, the equation changes a little bit because, you know, at the edge you can reduce the number of ports. Well, when you go to the network core, you got the same amount of bandwidth you have to fly around. It's both, you know, your Ethernet traffic and also your storage traffic, which means the total amount of bandwidth is going to be roughly the same, which means the total number of ports is going to be probably comparable. And so you don't necessarily get as big of a savings that way. And, you know, so then it, you know, comes down to, okay, well, CapEx savings may or may not necessarily be applicable. It really is a question of, is there OpEx savings associated with it, and operational savings. In order to take advantage of that, that means you have to have a model where you're managing both Ethernet and storage over the same wire. And today, most organizations have two different teams managing those things, one for Ethernet, one for storage. And so you get a question of, okay, you can merge the wire, do you have to merge the teams or not to go manage that stuff? And that's one, you know, you get to kind of some of those cultural questions, and is it worth it or not worth it, because you're not really getting necessarily CapEx savings to do it. So, you know, is it worth the trouble to go make those kinds of changes? And that's something where I think, you know, we've seen, like I said, a lot of, you know, questions, you know, come up about, you know, people talk about fiber channel Ethernet, or people implement it right away. There's standards questions that, you know, have been continuing to evolve and stuff like that, and it seems to, you know, when you're done, is the benefit overwhelming? And I'd say the jury still seems to be out, you know, in the industry as to, you know, how compelling the benefit is going to be for that. So at the edge, we think it's great. We've actually implemented on the motherboard of our servers at the core. It's definitely technically doable, you know, going forward in the future with some of the evolving standards and stuff like that. But we're not necessarily seeing as, you know, as rapid of adoption from that side of things. Other one, you know, convergence, point of convergence is servers and storage. And I think this is an interesting one also. We've seen storage architectures evolve a lot. You're going to hear a little bit more about that a little bit later on today in one of the presentations. But we've seen more and more people saying, you know, I want to move the compute to where the storage is. And so we've got some platforms. I don't know, we're going to show the DL180, Dan, or today, or talk about it? Or
We've got one in this room. So we're going to talk about the DL180.
Yeah. Okay. Great. Well, you know, so we've got some, you know, platforms where people are putting a lot of storage and compute together because it just makes sense for the kinds of problems that they're working on trying to solve. And we're seeing more and more, you know, of that class of problem emerging, where, you know, they're doing, whether it's, you know, a lot of data analysis or whatnot, where you want to have the compute right next to the storage, and so you want to merge the two together. So, fabric-based computing, you know, this is actually Gartner's conference in last month. That was, I don't know, one of the biggest topics on it. Duncan, you were there, weren't you? So, yeah.
Patrick was there. I was in
Okay.
APJ.
Okay. Yeah. So,
but I'm very aware of what went on.
yeah, it was. I know it was just one of the biggest
It was.
discussions, you know, there. So.
Both are new taxonomy and fabric computing, which is more equivalent towards our CI, and then they would drill down to fabric-based infrastructure, which is more specifically focused on fabric.
Yeah. Yeah. In fact, actually, I heard, I wasn't in the, you know, this one, but one of the sessions, one of the Gartner guys even talking about it, and he called it converged infrastructure. He was like, he was like, yeah, I think I'm talking about HP now. You know, so, yeah.
Like that.
Yeah, so, But fabric-based computing, I think in general is kind of what Gartner calls it, stuff like that. We've been doing this actually for several years with Virtual Connect. Jim talked about that earlier today. We think that what we're doing with Virtual Connect and the direction we're going, we're really builds kind of a fabric around the compute infrastructure, which frankly is a great enabler for things like cloud infrastructure, where you want to go and say rapidly, instantly provision the server infrastructure, provision IT infrastructure on the fly. It is an enabler for that. It's an enabler for convergence. It's an enabler for for being able to move workloads around dynamically across the fabric. And so we've been shipping this now for, it'll be 4 years next month, actually. So I'd say this is an area where we're probably old pros at, and I think you got a whole session on this one too, if you get to hear more about that coming up later also. Culture. I think this is always kind of the what I say, the moose on the table, or the white elephant, or the elephant in the room, or whatever analogy you want to use. Someone got even more creative than that one, honestly. But the question is always lurking behind all those technologies. Is like, well, what does this mean to me? And when we go talk to customers about convergent infrastructure, and I know Duncan, you probably experienced this too. Some customers will bring it up explicitly. Others, you can just see kind of almost the fear in their faces. They don't want to say it out loud, but it's like, what does this mean? How do I deal with it? Stuff like that. And I think, especially with like converged infrastructure, one of the first thing that people think is, well, if you're going to bring together compute and storage and network, does that mean that we have to merge all those teams together into one team, and suddenly everybody's going to be an expert on everything? And what does that mean to my organizational structure, to my job description, and how do I deal with that and stuff like that? And I think that's a valid concern people have, but I think at the same time it's probably the wrong approach to go do it. I'll take the kind of the radical position, saying that there's a reason why we have expertise today around server expertise, storage expertise, network expertise, even facilities expertise, and because that expertise exists, you want to keep it intact. I mean, you don't want to have a server administrator inadvertently take down the whole network because they didn't understand how to configure a switch, and you didn't want a network administrator accidentally deleting somebody's data because they didn't know how to configure the storage array correctly, or a storage admin accidentally taking down a critical application because they didn't know how to configure a server. I mean, there's reasons for that expertise to exist, and so in our view of converged infrastructure, we still have to maintain those roles in those areas of expertise. And so really, it's converged infrastructure from a management standpoint. It's not about eliminating the roles in the data center, but really about making them work more efficiently together. And so things like, rather than saying every time I need to deploy a new server, the network person has to drop what they're doing, give me an IP address, or as one network administrator said, aptly says, I'm sick and tired of being a human DHCP server. That's the way they described it. We need to figure out a smarter where the network administrator, the storage administrator can say, here's the rules about how you can use infrastructure, and then when you need to use some, you can use it according to these rules, and as long as within these rules, you can get what you need. And that's a model that we proposed with Virtual Connect, and it's been very well accepted. We've got millions of ports out there in the marketplace using this technology today, so we know that this stuff that customers embraced and like and stuff like that. And we think that's really the right model for the future, is rather than saying every time I want to do something I have to get 2 or 3 people involved to help me make that decision, we need to be able to say, hey, let's kind of define the rules of engagement up front, and then allow people to consume the resources that go. And we think that model works for converged infrastructure, but it's also, when we do that right, it makes converged infrastructure the perfect platform for clouds, because cloud computing is really the extension of that model. And that's a model that we know well, our customers know well, because they've been using this approach for several years now, in some cases with us. and it's something that we think makes sense. So you want it with then the question is, well, what are the cultural changes? Well, the shift isn't away from saying you have to learn how if you're a server expert now you have to become a network and storage expert too. It's more of we just need to think about how to work smarter with the network team and the storage team, but everybody still does their job. We just collaborate in a smarter fashion. And then when you start moving to saying, well, it's not just about assigning IP addresses or assigning a storage line, but it's assigning an entire workload, maybe a complex application, composite application or something like that. I can do all that. And actually that's kind of where we've gotten to with Blade System Matrix, where we can do an entire application all at once, based on the rules that are predefined. And so then when you get to that level, you say, okay, well, gosh, which application should I do this with? I'm moving to a cloud model at this point. What apps should I move to the cloud? To your question earlier, should I move my critical apps first, or last, or never, or whatever? Do I want to think about having an environment that's not just internal, but also ultimately being able to pick and choose whether I do it internal or outsourced, or things like that. And so I think this really gets to the heart of the cultural questions, even in a cloud, is what's the right approach to take advantage of these things. Again, we probably have an opinion also. Probably everybody does, but we think that it's one of these things where you want to kind of pick off something bite-sized first. So maybe it's simple applications that are high volume internally, or maybe it's a test and dev environment, depending on the particular customer, something like that. And then build a cloud small and kind of grow from there. I'll go back to I think the clouds are ultimately kind of where everybody wants to get to, but you got to start somewhere. And you kind of think about it, it's kind of like virtualization. Everybody's using it pretty broadly now, but you started somewhere. You didn't use it everywhere day one. You said, okay, let me just pick something and kind of grow from there. And I think clouds are going to be the same way as customers say, gosh, I know I want to get there, but where do I start? So let's start small. Let's pick something and grow.
So one of the things I've seen culturally that gets people to buy in is the idea that you move out of everybody constantly being in maintenance mode in the organization and moving into actually getting to do cool new projects and participate in the cool new projects.
Yeah.
And a lot of the convergence allows that to happen, because by setting up things like a virtual connect or using some other cloud infrastructure, it makes it easier for the actual end user of the product to go say, here's what I need, and they don't have to go to 6 different gatekeepers of the various resources. They just go in and say, these are the resources I need, and they get handed off fairly automatically, which reduces the number of meetings and back and forth emails and phone calls to try to chase everybody down to get the work done. And I think it actually, from what I've seen, reduces a great deal of friction within the teams that are all providing resources in an organization, because people aren't dreading having to go to those meetings to talk about, this is a project I don't care about, but I'm a de facto stakeholder just because I have resources that you need.
Right, yeah. So you probably get the human DHCP server.
Yeah.
You probably know one of those. So, and actually that brings up another really good point too that I always kind of think about is, and it's like I said, stuff you don't care about. A lot of it is really mundane kind of stuff that you have to do because it's just the way you got to do it. And I think people would prefer not to have to do lots of mundane, repetitive tasks if they can get around it and do the more creative and interesting stuff instead. And so, I think that if we do it right, it's freeing in that regard, and we can really go off and work on the cool new stuff. One of the things I go ahead, Duncan.
Yeah, so I actually think this part of the discussion actually is quite pivotal, because, for the technology to be there, that's fantastic, but unless we kind of enable the organization to embrace and accept it, and as you stated, the right motivation, that's quite key. So 2 things that come to mind, at least I'm hearing from customers. One is just an understanding and the level of kind of objective assessment of their maturity level. So not everybody is ready to take either, definitely not a transformational step, unless there's some great business reasons to do so, and you can go there. But in a lot of cases, it's understanding, okay, well, what is the next building block type of approach? What's the next step I can take, let's say, like with Virtual Connect, like with Blaze, let's say with some type of, some very creative unified management. So one is just this maturity level of the organization to accept that change. And the second one for me is just around general governance here. So we talk about cultural and process changes. The other thing that I've seen that's positive in terms of creating centers of expertise or governance to make those decisions, as you say, Gary, up front.
Yeah.
And the more they understand that up front, let's put in place that governance, because if there is going to be some technology advantage to make sure the processes and communications are in place to understand, okay, we're going to pick off this app first, or we're going to go for this level of convergence.
Mm-hmm. Thanks. One of the things I think of kind of is one of the reasons why I did converged infrastructure, the kind of the description you just gave, Jake, the challenges that you have. There are a lot of customers have that kind of challenge, and a lot of customers don't even want to talk about how bad it is because they assume it's them. But whenever it has the same challenge, it's like, well, maybe the problem is somewhere else. They couldn't all uniformly have the same exact problems. And really, I would argue it's actually the architecture of the IT infrastructure that's built in the data center is the problem. I mean, as an industry, the way we have defined the boundary of what is a server and what is a switch and what is a storage array and a SAN switch and all these things like that have actually forced all this complexity upon our customers. And so I think it's really the fault lies collectively with IT industry. It's our fault. But I think that's really also the opportunity, and this is where HP has been so so enthusiastic about converged infrastructure. We really want to kind of take charge of fixing the problem that we created. And it's not just HP that created it. I mean, everybody else was there right along with us creating the problem. But we're really trying to take a position of saying we know how to solve the problem, not fix the problem. Let's go do it. And you see us kind of creating these converged solutions that really, take advantage of better ways to help people work together to go, simplify life and make it a lot better.
Doesn't it seem to say that the SMB space is typically slow to adapt to new technology or to go out and grab new things? But converged infrastructure could be something that helps them because they might have one or two or three jack of all trades type people doing everything with switches and routers and servers and everything separately, where something like this could
I don't know. In Seattle, SMB is who I see like really readily adopting this stuff like this because it makes it easier to scale up. You get to the point where you're like, do I need to go out and hire more people, or do I have a IT infrastructure solution that allows me to keep using the same people and not have to massively expand my organization in order to scale?
Or more importantly, if that person is not even in town.
Yeah.
Out of state, whatever. Yeah.
Yeah, I mean, and it also makes the advantage of you don't necessarily have to have the people on site, depending on how you're deploying.
Mm-hmm. Yeah, so I think there's your answer.
Thanks, Jake.
Let's switch gears for a second, talk about data center environmentals and stuff like that. And so you heard a little bit about our pod. You're going to see a pod today, right? So, which are really cool. The neat thing, we're doing a pod tour, right? Okay, you're looking at me like, do you switch the agenda on me? So, the pods actually are cool. I mean, they're temperature cool.
Yeah, no, that's what I was laughing
I mean,
so, pun intended.
Pun
intended.
But I'd say probably 4 or 5 years ago, we were getting to the point where the computing densities were outpacing our customers and our ability to power and cool in an adequate way. So I'd say extraordinarily common for people to have racks that are mostly empty. And there's still a lot of customers out there with mostly empty racks because that's all they can power and cool. So I think we've made great strides as an industry, and certainly HP has been, I think, leading the way in this in terms of getting handle on the power consumption, reducing the power consumption, just the sheer maximum power consumption, but also managing power in a more dynamic way. And I think over time that's just going to have to become kind of a commonplace for systems just to dynamically adjust their power consumption based on the actual amount of work they need to do in any given time, and you see them become more and more linear in the way that they do that. And then we've also started doing technologies like power capping, which allows customers to put an absolute maximum amount of power that can be consumed over a group of servers, and then you can put a cap at that point. Typically, you set the cap such you'll almost never likely hit the cap, but then what it allows you to do is allows you to put more servers on a given data center circuit. And given that a circuit now is, Uptime Institute says about $25 million a megawatt of power, or for me it's easier to think of it as $25,000 per kilowatt of power. And if you figure data center's got a 25-year lifespan, it's a nice easy round number here, that's $1,000 per year per kilowatt of power that you plumb in a data center. And so, if you have like one of these blade chassis that takes 8 kilowatts in for 6 power supplies, and that's $8,000 of amortized cost per year. Well, you better figure out how much stuff you can shove in there, because the more you can, the better asset utilization you're going to have. And of course, with many customers saying they're running out of power in their data center, this is a real problem, because running out of space in a data center means either having to go colo or build a new data center, which is usually a board of directors discussion. So it's one of those things you really want to get the most use out of the data center you have. And so we think that technologies like that are critical. Now, the other thing that we've seen though in recent years is we've been doing a tremendous amount of work on cooling technologies also. So not only get the power levels down, but then also get better at cooling stuff. And so we have things like our modular cooling system racks, which, let's see if I remember the number right, but we can do like 30 kilowatts in a rack that we can cool, which is a tremendous amount of power to dissipate out. And when you see the pods, you'll see some just stunning capabilities we have there in terms of what we're doing to cool things there also. And as a result of all this, what we're seeing again is we're starting to see customers stuff more stuff in the racks again. And so, for the first 10 years or so of industry standard servers, we saw people just fill up entire racks full of IT gear, and then they started going, oh, can't split as much, and so it's kind of getting less full. And now we're starting to see a trend again of people starting to cram more stuff in the racks again. So I think we're as an industry starting to figure out how to get in front of the game again. But certainly HP is doing this, where we're starting to get the ability to power and cool more stuff in a rack. And it's been a combination, like I said, of a lot of different things. I think things like pods, is a growing business for us, as you heard Jim talk about before. The interesting thing about pods is, it's modular, so you can buy the amount of capacity you need when you need it, and we can get it delivered in a matter of weeks. But it actually delivers, because it's a self-contained environment, you can deliver more efficient power and cooling than you can in a traditional data center. Traditional data center, you think about it, you just have air coming in and then the air goes out, and it just kind of goes where it wants to go, and you try to make it go where you want it to go, but there's just too many opportunities for it to go somewhere else. And with a pod-based computing environment, we can really route the airflow much more efficiently and be able to handle it better. By the way, any of you guys know what percentage, if you add up all the power in all the data centers in the U.S., what percentage of the total U.S. power budget it is?
3%.
I think that's probably about right. Yeah. So we're a non-trivial workload. Yeah, load on
It's
the.
actually growing quite
I heard
fast.
the data before in the past.
So Calvin, you're right, it's around 2%, but it's probably the fastest growing component of that when you actually break it out.
Mm-hmm. So it's a real.
Surprisingly low. I mean, you would expect it to be higher.
Well, there's an awful lot of. That's just for the data centers. It's not the total computing power. It's just for the data centers. But there's an awful lot of other stuff out there consuming power, and obviously it's growing. And our goal is to figure out how do we, in aggregate, grow computing power at a much faster clip than actual, number of kilowatt power, or even ideally actually reduce it. As one of the discussions earlier that, triggered a thought for me. Actually, some of the most aggressive companies, actually, they are, Jim G was talking in the earlier presentation about the ROI, 30-day ROI and stuff like that. A lot of companies, what they'll tend to do is they'll tend to hang on to servers for as long as they can until they crap out. But the problem is that you may have something that's literally like 30 times less power efficient than what a new one is. And so it's like, as it turns out, it's vastly cheaper to buy new stuff and run on new stuff than it is to try to keep your old stuff that's already paid for running.
But the business side of the house likes the old, slow, paid for equipment, and not the new, hey, we gotta go buy this.
It's
And they go, by the way, we're
when
running
you-
out of space, let's go ahead and build another data
Yeah.
center to keep on running our old, slow equipment.
That's when the IT person needs to really explain ROI and why it's so important to do that. I mean, as an IT administrator from the old era, we used to have servers that we would bring up from time to time. We'd have old computers we'd bring up from time to time to turn into web servers or extra servers. I was always constantly explaining that to him. The only thing that we had an advantage of was we had a virtual area where I could actually back up servers and bring them back up on server to server to server. But for the most part, if we needed another server, they just said, well, just take this box and bring it back up, and you had to go through that again and again and again. That's not going to work because within 6 months that server is just going to be slow. Everybody's going to complain about it, and we're going to lose a lot of money off of it. So
Yeah.
But that depends who controls the budget strings. If the application team see money being taken out of the budget, they don't want to spend money on servers. If IT controls the budget and sells the concept as a service,
Yeah.
you have an application, you need a virtual machine or a new server, then we'll spend that budget on that.
Yeah.
It's also that the people that were supposed to be told about this kind of stuff never did.
Yeah.
It used to be a server guy or a networks guy saying, your switch is old, can we have a new switch? No. Computer says no, budget says no. And then you say to application teams, okay, well, why do you not have budget for servers? Because we didn't put it in. Because well, didn't you think you were going to spend any money on servers now? Don't want to spend money on servers, we can reuse the dev kit and so on.
and then
But
that's
then
just
it's
emergency
because
fund.
we're not taking the business view or the marginal cost view, in that it's cheaper for IT to say, okay, I would like 4,312 paperclips. Insert server number 9. I'll buy you a server and charge it back, or not charge it back, and realize that it's better to buy a new server than it is to let someone run on a really old legacy platform. But then you do have the application cost of some of the stuff is just too old and can't run on anything relatively new.
That's where return on investment comes in. If you can explain to that budget person, even if there is no budget, to say there's a return on investment in 3 months, 6 months, then it becomes a lot easier to actually explain.
And actually, that's where cloud computing can come in handy, because you can get something deployed at a fairly low cost, prove out that you have given them a benefit, and then say, oh, by the way, if we want to keep this long term, you're going to have to spend a little more money.
Oh, you're right, but it's the BAU thing, it's the non-cost thing. I pay, I don't know, £400,000 to run my infrastructure and my application, so I know I've got to pay £400,000 a year. If you turn around and say, okay, it's going to cost $2 million to refresh your hardware, recode your application, validate it, and sign it off, I might turn around and say, well, don't care what you say, it's a fixed cost. You're moving to a variable cost, and I need to turn around to the board or someone important and say, I can spend £2 million. It does depend on where you are in your enterprise and how effective you are communicating with each other.
That's where semantics, logistics, and being able to explain yourself come in really well. I mean, I could ask you spare change, and you could say, I don't have any, and you have change in your pocket. But if I said spare change, and down the block you'll find yourself $1, will you give me change then?
Yeah.
Depends on how much change you want. You want $1? No.
Well, I'm for hope and change. So let's and I'm going to finish this up, and we can go on and get on to the fun stuff. So the last one I put on is taking out complexity, and I think this is one where it gets overlooked a lot, because we always want to talk about the cool new technology and the new thing here and there and stuff like that. But behind all the new technologies, the industry has this habit of kind of leaving this mess of complexity behind it, in terms of keeping stuff up and running, because they're all different, stuff like that. And this is where, you know, we've put a lot of emphasis on things like our convergent infrastructure strategy. We're really trying to bring things together, to simplify things, to reduce the number of possible variants that you have to worry about and stuff like that, and do things. You know, things like blade system where, you know, it's the same power supply, same fans for every different workload you have, whether it's Windows, Linux, Unix, doesn't matter. It's just, you know, there's a lot of things exactly the same, so you can kind of simplify things a lot that way. You know, we think that, you know, this is going to be an important, you know, point here, and, you know, even if you're moving everything to the cloud, you got to depend on someone else who can manage that complexity for you, not, and the simpler we can keep it for them too, the better. And we see that that is a really a crucial thing. So you'll see us continue to do a lot just to simplify user experiences, reduce the complexity with managing our products and so on. And then also some innovations, things like our cloud maps, where what we can do is we can take the whole complexity of how do you deploy, you know, a complex application, Exchange or something like that. And we've reduced it down to ask a few simple business rules, like, you know, how many users, you know, how many mailbox seats do you want, how much storage do you want for each mailbox, kind of a questions. And then based on that, we can create a complete description of the infrastructure you need for the application. So, you know, all the compute, the storage, and so on like that. And that description is called the cloud map. And the cloud map can be put on a blade system matrix today and automatically instantiated. And then voila, you get that infrastructure for you. So reduce the, you know, from a, like, you need to know the business rules, do you need to know the IT rules, do you need to know how to configure the systems, down to you just need to know the business rules. And then everything after that gets automatically handled.
But Gary, I think that last point's important because it's not just about reducing some of the actual costs, but it's actually really improving the actual systems manager's productivity.
Mm-hmm.
So I think that's kind of where, you know, well, so what? I mean, I think it's very relevant when people think about jobless recoveries, people want to enable growth. You're not going to get more staff if you're expected to grow. So if you can actually help out with the actual system manager productivity, it's a big deal.
Yeah, yeah, I think so. And that's, you know, where we've seen great success with, you know, products like Blade System is, you know, customers just love the fact that I can just keep on putting more and more stuff in, different kinds of stuff, but it has so much exactly the same behavior, you know, from the other stuff they've done, that it, you know, I don't have to relearn, retrain, redo, you know, different stuff. I don't have to worry about, wait, if I do it here, I have to remember to do it different than I did it there, and stuff like that. So, you know, it ends up just simplifying, you know, quite a bit. What I want to do is I want to hand it off because I know I'm running too much long.
One question. Kevin Houston was supposed to be here. He got stuck in Atlanta because of the snow. He sent a question on Twitter. Do you mind answering that?
Oh, I'm trying.
He said, if a customer doesn't want to benefit from Virtual Connect, are there any other advantages over a traditional switch? And by benefit, I mean they aren't going to use the abilities that VC offers, like never-changing WWNs.
Okay, so are there still benefits of Virtual Connect?
140 characters.
That was true. I'll read it one more time. Okay. If a customer doesn't want to benefit from Virtual Connect, are there any other advantages over a traditional switch?
Yeah. Yes.
Yeah.
So even if, and actually, I'll answer it partially, but ask it again from the Virtual Connect team, and they may come up with some other things too that I've neglected to mention. So you know, Virtual Connect is, you know, I mean, it's got, you know, the ability to migrate worldwide names and MAC addresses around from one place to another, but it also has the ability to just straight up, when you deploy Virtual Connect, it simplifies the initial setup of the environment because you pre-assign all the MAC addresses and worldwide names one time versus multiple times. So it can simplify the initial provisioning of server. It can also actually simplify things like the network and SAN environments also, because they look like one big endpoint to the network, and so it winds up simplifying the network design on the other side of it. And actually, in the cases like storage side, you can actually make your SAN larger because the SAN has a maximum number of switches you can put in a fabric. Well, Virtual Connect is not a switch, so you can actually put 16 times more endpoints on than you can normally put onto a fabric, you know, with Virtual Connect present. So you can actually get that as well. And then the last thing also is Virtual Connect, whether you choose to use it or not, has, you know, from the mobility stuff like that, has the ability to carve up the multiple MAC addresses, or excuse me, the multiple NICs and adapters that allows you to and then assign the bandwidth out however you want to. And that's something that's just implicit in the initial setup of it. So if you're using it, you can have that feature turn on. So you wind up saving CapEx and reducing the parts count that you need to set things up also. So there's a lot of things, and this really gets back to kind of what I talked about, kind of the fabric-based computing things. I think that there's a reason why people are wanting to move that way, and Virtual Connect, I believe, is the and I'm not just saying this because I work here, but because I really do believe this. Virtual Connect really is kind of the poster child for where we think people want to move to with fabric-based computing kind of environments, because it does so many of those different kinds of things that you don't get in a traditional servers connected to switch topology environment. Okay.
Thank you.
All right. So with that, we're moving on to the next topic, right?
Yes. Dan stepped out. I'll grab him and Jim.